Hello everyone, today we are going to perform an experiment which is related to the comparison of the EMF of the two primary cell by using potentiometer. Now in this experiment we are using a device called potentiometer which consists of 5 to 6 wires, each wire of length 1 meter. Now the potentiometer works on the principle that the potential difference across the end of the wire is directly proportional to the length of the wire. That means if V is the potential difference across the end of the wire and the L is the small l is the length of that wire, in that case V is directly proportional to the L, small l. Now as per Ohm's law, the potential difference across the end of the wire is directly proportional to the current flowing through that wire. In that case V equals to IR, and the resistance of that wire is equal to the rho L upon A. In that case R equals to rho L upon A. If you put the value of R in the equation V equals to IR, we will get uh, V equals to I rho L upon A. Now V upon L is equals to I rho upon A, where I, rho and A are constants, so V upon L is also constant, and which is equals to the small k, which represent the potential gradient, and the unit of potential gradient is volt per meter. In that case we have V equals to K times of L. Now we can use this relation V equals to KL to derive the formula to calculate EMF of two primary cell. Now suppose if this Lagrange cell is only connected with this circuit, in that case the EMF of this Lagrange cell is going to be considered as E1, and corresponding balancing length is taken as L1. In that case we write E1 equals to K times of L1. Similarly, if only Daniell cell is connected with this circuit, then the EMF of this Daniell cell is taken as E2 and balancing length is taken as L2. In that case E2 equals to KL2. Now we are going to take the ratio of E1 and E2, that is E1 upon E2, we get L1 upon L2. Now by measuring the value of L1 and L2, the ratio of E1 and E2 can be calculated. In this way we can find out the EMF of two cells through this formula. Now the apparatus required while performing this experiment are jockey, potentiometer, plug key, rheostat, galvanometer, Lagrange cell and Daniell cell. The figure of Daniell cell and Lagrange cell are shown in this slide. Now we have a figure here of a potentiometer in which a ammeter is connected in series with rheostat and the battery. The positive terminal of the battery is connected to the point A, at which the positive terminal of Lagrange cell and Daniell cell are also connected. The negative terminal of these two cells are connected with the two-way key here at the point A, B, and at point C a galvanometer is connected through a jockey, and this jockey is free to move on this wire. Here the rheostat is used as a variable resistance, and the current supplied from the battery can be measured by this ammeter. Further, we have an observation table here which consists of ammeter reading null point when E1 is in circuit and its the corresponding length L1 and null point E2 and its corresponding length L2, and we have to write these readings in this table, and we have to take the ratio of this L1 and L2, and through that we are going to find out the ratio of this A1 and A2 by putting the value of this L1 and L2. While performing this experiment, we must have to take some precaution here, like that all the connections should be neat, clean and tight. Do not keep the connection of the circuit for a long time. The positive terminal of the batteries E1 and E2 should be connected at point E. We have some sources of error arises during performing this experiment, like the screw on the instrument may be loose, the plug may not be properly inserted, and the wire may not have uniform thickness. Perform this experiment here. Now if you see this is a device which we call potentiometer. It consists of 4 wires, each one of length 1 meter or 100 centimeter, you can see. This one is the scale to measure the length of that wire. Now we have this rheostat which is used as a variable resistance. This is the battery here, which has positive and negative terminal. This is the Laclancy cell which we already discussed in the slide. This one is the positive electrode, and this zinc rod act as a negative electrode. Now, this one is the two-way key, plug key. This is again a negative electrode, and this copper vessel act as a positive electrode. Now, if you see this, the negative terminal of this battery is connected to the one of the terminal of the rheostat, and which further connected to this terminal B. Now, the positive terminal of this battery is connected to the terminal A, and all the positive terminals of the cells, primary cells, are connected with this terminal A. Now, the negative terminal of these cells are connected to this key, plug key. Now this galvanometer is connected through this key again. Now the another terminal of this galvanometer is connected to the jockey, which move on this wire. Now we are going to take the reading in this experiment. For that we remove a key from this plug key. In that case, this Laclancy cell is connected with this circuit. Now we are going to take the reading. Now if you see this, you are getting a null point, and now correspondingly we are going to measure the length of the wire here, which is around 203. The galvanometer shows null deflection here, and we are going to just measure the reading here, which comes about, if you see this, which comes about 200. So this is the null point, and we can measure the length of the wire. We can measure the length of the wire. It is 203 centimeters. Now we can put the reading in this table here. Now we are going to write down the reading here, that is 203 centimeter when this Laclancy cell is connected in the circuit. Now one important thing I am going to tell you here, the ammeter is not necessary to connect in this circuit, so we are not taking the reading of this ammeter. We are putting dash over here. It is not necessary to put ammeter in this connection here. Now again we are going to find out the balancing length for the Daniell cell. For that we are going to put key plug key in this two-way key. And now this Daniel cell is connected in the circuit, and we remove the another key. You see this? The only Daniel cell is connected in this circuit here. Now we are going to take the reading again. Which comes around, you see this, 143. We are going to write down the reading for the balancing length is 143 centimeter. Now we have these two values. The balancing length when Lagrange cell even in the circuit, that is 203 centimeter, and the balancing length when the Daniel cell in the circuit, in that case the length of the wire is 143 centimeter. We are going to take the ratio of these two and find out the ratio of this EMF of these two cells, that is 203 upon 143, which the value of this is comes out to be around 1.41 that comes out to be 1.41. Now similarly we can find out the another reading when these cells are connected in the circuit. Thank you.